So see, our project is running. We have this main files, train, which is for indexing, test one, which is for retrieving the similar images, feature for feature extraction, depth extraction for seeing how the features are being extracted. So we'll start with depth extraction. Okay, if we execute depth extraction once, we'll select any image. The objective of this file is to extract the depth map and demonstrate how the features are extracted. What exactly is a depth map? Any image is of course represented in a two-dimensional fashion. This image is represented in a two-dimensional fashion. So you have only x values and you have only y values. We see basically this image has got certain thing which you are seeing in front of you. There are certain objects which are a bit away from you. So in 2D space we cannot render these values. Okay, this we call Z map, okay, or depth map or Z axis. So the first objective is to extract the depth map from the image. Now how do we extract the depth map from the image? It's very simple. We first calculate the mean value of the image, subtract mean value from all the pixels, and we calculate the P and Q component, which are nothing but interrelationship between one Z component with another Z component. Okay, and then finally we filter that using this equation. Now this Z map is nothing but the one that represents the image in the three-dimensional space, and that three-dimensional rendering can be displayed from the first image, which you can rotate in all directions to see. Now why certain values are 0 or why certain values are not connected is because this is just a single image, and from single image it is quite difficult to extract the entire Z map. But however, if you rotate the image in this direction, you should be still able to see how they differ. Okay, but this difference, okay, which we see over here, it is purely because there are some views which you are not able to see what is there in the background that you are not able to see. It's a single view. So whenever you rotate the image in such a manner that its background has to be visible, you get discontinuous values. Then again when you rotate it back in such a way that the image is in front of you, you again start seeing the Z values. Okay. Now once this feature are extracted, we first convert the image into binary image, then we extract the age from the image, and then we find out the contour. Okay, this contour is nothing but continuous points of x and y coordinate that outlines that Z map. So this is my contour. Now a contour may have several hundreds of points. So I'll run to see how this result is. I'll select one image. Observe very carefully here. This was the image I had selected. It had a box in front. It is selecting an image which has a box in front. It has also selected a similar image. See, it is entirely different from this image. It is rotated at a different angle. It selects this image also. Okay. There is a glass-like shape at the top. It has selected a glass-like shape at the top. There is also, if you observe this, there is a round shape. There is a round shape. It has selected this. All of them are cylindrical in shape. Because it possesses a cylinder, it will be able to retrieve all these images. Now I'll change my query image. I'll see what the result is. Now I'm going to select one car image. For that car image, whichever were the number of cars, it has selected all these cars, plus because its shape is almost rectangular, it has selected this one, and a couple of them are misdirection.